Hello children, our new topic is periodic properties of elements. Periodic properties of elements. This video class includes that periodic properties like atomic radii, ionic radii, ionization enthalpy, electron gain enthalpy, and electronegativity. In this chapter we are learning about 5 periodic properties, that is atomic radii, ionic radii, ionization enthalpy, electron gain enthalpy, and electronegativity. And what do you mean by periodic properties? Periodic properties are the properties which show a regular gradation, either increase or decrease along a period or along a group as the atomic number increases. The repetition of similar properties after intervals of regular intervals is known as periodicity, and it is the similarity in the outer electronic configuration which is responsible for the periodic properties. Okay, so that is the properties which show a regular gradation, either increase or decrease along a period or in a group as the atomic number increases. And the repetition of the same properties after regular intervals is known as periodicity, and because of the common electronic configuration or the same electronic configuration that elements are possessing that. The first periodic property is atomic radius, and it is defined as the distance from the center of the nucleus to the outermost shell of the atoms. Okay, outermost shell of the atoms. It's written as electron. You make the correction. It is the distance from the center of nucleus to the outermost shell, and it is the radius of an atom itself. It is the radius of an atom, but the determination of exact atomic radius is not possible because of very small size of an atom and its non-sharp boundary. Because of these two reasons, we cannot measure the exact radius of a atom. Okay, so atomic radii can be of 3 types. The first atomic first type is metallic radius. From the term itself, it is the 1/2 of the internuclear distance. What do you mean by internuclear distance? Distance from the center of the nucleus to the outermost shell. Okay, so metallic radius is 1/2 of the internuclear distance separating the metal in the metallic crystal. So in the case of metallic structures or metals, we can use, instead of an atomic radius, we will call it as metallic radius, and it is the 1/2 of the distance, internuclear distance between centers of the nuclei, that is internuclear distance between the metal atoms. Similarly, we have 2 more, that is Similarly, we have covalent radius. It is the 1/2 of the internuclear distance of 2 covalently bonded atoms of the same element in the molecule. That means the bonding between the atom must be a covalent bond. The next one is very important, van der Waals radius. It is the 1/2 of the internuclear distance between the nuclei of 2 identical non-bonded isolated gaseous atom. Identical in the sense same type of atom must be there. Non-bonded means there is no bond between the atoms, and that is they are known as isolated gaseous atom. So 3 different types of atomic radius. In the case of metals, we can call it as metallic radius. If the bonding is covalent bonding, then we can call it as covalent radii, and if there is no bond or isolated gaseous atom, then we can say that it is van der Waals radius. The atomic radii generally increases on moving down a group. Because as the atomic number increases, the number of shells are also increases. As the number of shells increases, what will happen? The size of the atom is also getting increases. So if you are moving from top to bottom in a group, the atomic number increases. At the same time, atomic size or atomic radius also increases. Similarly, the atomic radii generally decreases from left to right along a period, because with the increase in atomic number, the electron is added to in 3D or added to the same subshell. The effective nuclear charge increases, and hence outer electrons are held tightly by the nucleus. As that electrons are held tightly with the nucleus, the distance between the outermost shell as well as the nucleus decreases, so that size of the atom is also decreased. So there is a correction, the electron is added to the same subshell. The second periodic property is ionic radius. It is defined as the effective distance from the center of the nucleus of an ion up to which it has an influence in the ionic bond. So in the case of ions, that means positively charged ion, that is cation, and negatively charged ions, that is anion. The internuclear distance, half of the internuclear distance is known as what? Ionic radius. So our next type of radius is ionic radius. So it is in the case of ionic compounds. And the size of the cation is smaller than its parent atom, because a cation is formed by the loss of electron, but its nuclear charge remains same. Okay, and the nucleus bind the electrons more tightly, and the effective nuclear charge is increased, and the size of the atom is decreases. So in the case of, for the exam, they'll be asking why the cations are smaller than parent atom. Okay, then similarly the size of the anion is larger than its parent atom, because an anion is formed by the addition of electron to isolated gaseous atom. As a result, repulsion among the electron increases and the effective nuclear charge decreases. So that the size of the anion will be always greater than the parent atom. Okay, ionic radii show the same trend in the periodic. That ionic radius will show the same trend in the periodic table as shown by the atomic radius itself. That means if you're moving from left to right in a period, ionic radius decreases, but if you're moving from top to bottom in a group, it increases. And that species includes cations, anions, or neutral molecules which are having same number of electron but different nuclear charge. Nuclear charge in the sense number of protons are known as isoelectronic species. The species with the same number of electrons but different number of protons are known as the isoelectronic species. So in the table you can see a large number of species which are having identical number of electrons, and they are known as isoelectronic species. In the table you can see some of the species. First species is neon. It's a neutral atom. It is having atomic number 10, and the number of electron is equal to 10, number of proton is also 10. But in the case of sodium, the number of electron, Na plus, it is 10, and number of proton is 11. Similarly, in the case of Mg2 plus, the number of electron is 10, but the protons is 12, and F minus also. So there are species which are having same number of electron but different protons, and this includes neutral molecules, positive charged species, and negatively charged species. Next, third periodic property is ionization enthalpy. It is defined as the minimum amount of energy required to remove an electron from an isolated gaseous atom in its ground state so as to make it positively charged species is known as ionization enthalpy. Did you understand what is that? For example, the atomic number of sodium is 11, so the electronic configuration is 2,8,1, and the atom is not stable because of that one electron in the outermost shell. Metals are electropositive in nature, so that it is ready to donate the last electron, so that the electronic configuration becomes 2,8, which is having high stability. For that, we are supplying some amount of energy to remove the last electron, and it becomes Na plus, and that energy to make that atom stable by removing that last electron is known as ionization. Okay, so it is represented by delta H ionization, and the equation is for X is the atom. It will dissociate, it will releasing one electron and it become X plus, and delta H ion will be equal to ionization enthalpy will be positive. The ionization enthalpy can be expressed either in kilojoules per mole or kilocalories per mole, or sometimes it will be represented in terms of electron volt per atom also. Okay, so this is about ionization enthalpy. If we remove the first electron from the atom, that energy required for that one is known as first ionization enthalpy. Similarly, if it is second electron, that is second ionization enthalpy. If so, we will call it as second, third, or they are generally known as successive energies, ionization enthalpy. successive ionization enthalpy. In the case of alkali metals, second ionization enthalpy is always greater than first one. Second ionization enthalpy will be greater than first. If we remove the first electron from the atom, that energy required for that removal is known as first ionization enthalpy. If we are removing second one, that is known as second ionization enthalpy. If the next coming electrons we are removed, they are known as third ionization enthalpies or successive ionization enthalpies. Okay. In the case of alkali metals, the second ionization enthalpy is always greater than the first ionization enthalpy because the positive ion has more effective nuclear charge, which holds the remaining electrons more firmly, and hence large amount of energy is required to remove the electron. That is, it is very difficult to remove an electron from a positively charged species. And on moving from left to right in a period, ionization enthalpy increases. From top to bottom, ionization enthalpy decreases in a group. Next topic is factors affecting ionization enthalpy. There are 5 factors which affect that ionization enthalpy value of or magnitude of the ionization enthalpy. First factor is that screening or shielding effect. What is screening effect? Because of the presence of inner electrons, the outer electrons of the atom will not experience the full positive charge of the nucleus. That means they are shielded by the inner electrons because all the electrons are negatively charged. So when the outer electron comes closer to the nucleus, because of the presence of the inner electron, it gets shielded. This effect is known as screening effect. Greater the shielding effect, lesser is the ionization enthalpy. That's the first factor we have. Greater the shielding effect, lesser is the ionization enthalpy. Second factor is that nuclear charge. Greater the nuclear charge, greater is the ionization enthalpy. Second factor is greater the nuclear charge, greater is the ionization enthalpy. The third factor is atomic size. As the size of the atom increases, that magnitude of ionization enthalpy is less. That means less amount of energy is required to remove the electron. Then fourth factor is penetration effect. The order of penetration power of orbitals of the same shell is S greater than P greater than D greater than F. Greater the penetration effect, greater is the magnitude of the ionization enthalpy. And the last one is electronic configuration. If the species is having stable electronic configuration like D5, D10 or D0 configuration, then the ionization enthalpy will be greater. So these are the 5 factors. For the exam they will be asking what do you mean by ionization enthalpy, what are the factors on which it affects. It depends. Then or else they can ask directly state screening or shielding effect. Very simple one, study well. Okay, now we have some homeworks. That's exercise questions. Question number 1, what does atomic radius and ionic radius really mean? We have explained, and which is the question number 3.9. How do atomic radii vary in period and a group? That is also group we have explained. Question number 3.10. What do you understand by isoelectronic species? Give examples also. Question number 3.11. Explain why cations are smaller and anions are larger in the radii than their parent atom. Question number 3.13. Next one, why is beryllium has a high IE1? IE1 stands for first ionization enthalpy, then beryllium. Why, the same question itself, why oxygen has lower ionization enthalpy, first ionization enthalpy than nitrogen, fluorine? We have explained, and depending upon the electronic configuration you can write down. How would you explain, next question is that how would you explain the fact that IEM, how would you just explain the fact that the IE1 stands for first ionization enthalpy of sodium is lower than that of magnesium, but its second ionization enthalpy is higher than that of magnesium. So we know what is first ionization enthalpy, energy required to remove the first electron. Second ionization means ionization enthalpy means energy required to remove the second electron from the positively charged species, and we can explain what are the factors due to which the ionization enthalpy of main group elements tends to decrease down a group. Question number 3.1, we have explained the factors. Then question number 8, which of the following will have largest and smallest size? 4 species are given in text question 3.5. Try to find out all these answers and note down in your answer notebook itself. So we have explained the 3 periodic properties. First one, atomic radius, ionic radius, and ionization enthalpy. And the fourth periodic property is electron gain enthalpy, delta H Eg. Eg stands for electron gain, H stands for enthalpy always. It is the amount of energy released when an electron is added to an isolated gaseous atom in its ground state so as to make it a negatively charged species. Okay, once again, it is the amount of energy. In the case of ionization enthalpy, what we have explained is that it is the energy that we are providing to remove the electron. Here, the energy is released by the atom while accepting one electron. And the value of electron gain enthalpy or the magnitude of electron gain enthalpy can be positive for endothermic process or negative, that's for exothermic reaction. It is generally negative actually. Example, when an electron is added to halogen atom, they become highly stable. Their electron gain enthalpy value is highly negative. That is, for example, fluorine atomic number is 9, electronic configuration will be 2,7. So if you get one electron, it will be getting stability. So that halogens, they will be having a negative value of enthalpy, electron gain enthalpy. Instead of that halogen, if you are taking a noble gas atom, if you are adding one electron, what will happen? It loses its stability and they have larger positive values for electron gain enthalpy. Okay, so in the case of halogens, it will be negative. In the case of noble gases, it will be positive value. The value of electron gain enthalpy depends upon the atomic size, nuclear charge, and electronic configuration. On moving left to right in a period, the value of electron gain enthalpy becomes more and more negative. That means we said in the case of halogens, they have high negative electron gain enthalpy value, but in the extreme end, that is noble gases, it will be having positive value. On moving down the group, the value of ionization enthalpy becomes less and less negative, and they are telling that chlorine has the highest negative electron gain enthalpy with atomic number 17, 2,8,7. So all other parameters that like atomic size, nuclear charge, everything has to be considered for to find out the highest negative electron gain enthalpy. So chlorine has the highest electron gain enthalpy value. So electron gain enthalpy is the fourth periodic property. Then we have one question in text question 3.7. Which of the following will have the most negative electron gain enthalpy and which has the least one? So we have studied when we are moving across a period that electron gain enthalpy becomes more negative. In a group, it will be getting less negative. So as I said, chlorine has the highest value and phosphorus will be having least electron gain enthalpy value. So try to solve the problem. Okay, some homeworks are there from the exercise questions. Which of the following pairs of elements would have more negative electron gain enthalpy? One is oxygen or fluorine or chlorine. I'll find out the answer depending upon that trend in that electron gain enthalpy values. Second question, would you expect the second electron gain enthalpy of oxygen as positive, more negative or less negative than the first? Justify your answer. Question number 3.1, answer by yourself. What's the basic difference between the terms electron gain enthalpy and electronegativity? Since we have not studied about electronegativity, you can mention about that electron gain enthalpy value. Okay, write the general outer electron configuration of SPD and F block elements. That is question number 3.9 to 9. We have learned that one in the last video class. So find out the answers for all these questions and study. Once again, third question is what is the basic differences between the terms electron gain enthalpy and electronegativity? So instead of electronegativity, if it is electron ionization enthalpy, one is the energy that we are providing that to the system to remove the electron. Other one is system is releasing energy. The last one, write the general electron configuration. You have to do by yourself. And we have the last periodic property, that is electronegativity. What do you mean by electronegativity? It is defined as the capacity of an atom to attract the shared pair of electron towards itself. What is that? The capacity or ability of an atom of a compound to attract the shared pair of electron towards itself is known as electronegativity. And Linus Pauling has given, its name Linus Pauling. He has given a scale which is known as Pauling scale. According to that, fluorine is the most electronegative element with a value, Pauling scale value is equal to 4. Okay, fluorine is the most electronegative element, and this can be measured using what, Pauling scale. We can make use of that Pauling scale to measure that electronegativity. On moving from left to right across a period, the electronegativity increases because fluorine around group number 17. So if you're moving from left to right in a period, electronegativity increases, and from top to bottom in a group it decreases. So this is a factors that you have to learn, that once again, it is the capacity of an atom to attract the shared pair of electron. Fluorine is the most electronegative element. Moving from left to right, electronegativity increases. From top to bottom in a group, it decreases. So these are the fifth periodic property. Okay, then next topic is, what are the factors on which electronegativity affects? Okay, depends. So first factor is that atomic radius. What is greater the atomic radius, smaller the electronegativity. Greater the atomic radius, smaller is the electronegativity. Second factor, oxidation state. What is oxidation state? We know higher the oxidation state, higher the electronegativity value. Third one, S character. We have to study in that fourth chapter about hybridization. In that one, we will tell there are different types of hybridization: sp hybridization, sp2 hybridization, like that. So if the S character is getting increases, the electronegativity also will be getting increases. So these are the 5 periodic properties of elements in the periodic table that we will have to study. All these 5 parameters can be summarized, that is, trends in these periodic properties can be summarized as atomic radius. Second column is from left to right in a period, what will happen from top to bottom in a group. So what is happening in the left to right in a period, it will be just opposite to that of the top to bottom in a group. That also you have to keep in mind. So atomic radius we have mentioned already. In a period it decreases, but in a group it increases. Similarly, the ionization enthalpy, in a period it increases, but a group it decreases. Next one, electron gain enthalpy, the same pattern itself. From left to right in a period it increases, in a group it decreases. Last one is electronegativity. In a left to right in a period it increases, but in a group it decreases. Then metallic character. Metallic character in a period it is decreases, and in a group it increases. Similarly, non-metallic character, we know it increases in a period but decreases in a group. We know the left hand side of that periodic table they are metals, and right hand side of that periodic table they are non-metals. So if you are moving from left to right in a period, the metallic character decreases, at the same time non-metallic character increases. That's what we have to study. So this is a general pattern, and so many exception cases are there. We can write that all these periodic trends like this and study well this. So in today's class we have learned so many things, mainly what do you mean by periodic property, what are the different periodic properties that are possessed by different elements on the periodic table. Once again, there are 5 periodic properties are there. First one is atomic radii, ionic radii, ionization enthalpy, electron gain enthalpy, and the last one is electronegativity. And once again, one more point we have learned is that what are the factors on which that is periodic properties depend. Then along with that one, we have studied different concepts like isoelectronic species, and we have given so many homeworks also. So study well. And thank you for watching this video.